Hi everyone, here's our math challenge for today. So our question is very simple. Which one is greater? Is it logarithm of 12 to the base 11 or logarithm of 13 to the base of 12? We have 20 seconds to think and to answer this question. And timer starts now. Time's up. Now let's answer this question together. So the question is, which one is greater? Is it logarithm of 12 to the base 11 or logarithm of 13 to the base of 12? This algebraic solution is proposed by Master Juan Pablo on Twitter. You can follow him at JuanPB_78. Now let's go back to the question. First thing to do is to let a be equal to logarithm of 12 to the base 11 and b must be equal to logarithm of 13 to the base of 12. Now take note that logarithm of 12 to the base 11 is greater than 1, therefore a must be greater than 1, and logarithm of 13 to the base of 12 is also greater than 1. Therefore, we can say that a and b are both greater than 1. This is very important later on. Now at this point, let's convert this logarithm into exponential. Now if we have logarithm of n to the base of b equals m, it is equivalent to b raised to m equals n. Therefore, a equals logarithm of 12 to the base of 11 can be written as 11 raised to a equals 12. And b equals logarithm of 13 to the base of 12 can be written as 12 raised to b equals 13. Now take note of this 12. And this 12 is equivalent to 11 raised to a. Therefore, we can substitute 11 raised to a to this 12. If we do that, we get 11 raised to a raised to b equals 13. Now at this point, we will use some laws of exponent. If we have b raised to n raised to the power of m, it is equivalent to b raised to n times m. Therefore, the left-hand side must be equivalent to 11 raised to a times b. Now, let's set aside this result. Let's see how can we introduce some inequality. Now, take note that 144 is strictly greater than 143, of course. Now, 144 is just 12 squared, and 143 is just 11 times 13. Now we have 11, 12, and 13, and those numbers are what we want. Because earlier we said that 11 raised to a must be equal to 12. Therefore, this 12 can be replaced by 11 raised to a. If we do that, we get 11 raised to a raised to 2 is greater than 11 times 13. Now we will use again this law of exponent. So the left-hand side of our inequality becomes 11 raised to 2a. Now, this 13 is equivalent to 11 raised to ab. Therefore, we can replace this 13 with 11 raised to ab. Next, the exponent of 11 must be 1. Now at this point, we will use some laws of exponent again. If we have the same base, b raised to n times b raised to m, it is equal to b raised to n plus m. Therefore, the right-hand side of our inequality becomes 11 raised to 1 plus ab. Now since the bases are equal, we can say that 2a must be greater than 1 plus ab. Now at this point, let's subtract ab on both sides. So we have 2a minus ab must be greater than 1. Next, subtract 2a on both sides, and we have negative ab is greater than negative 2a plus 1. There's a purpose why we do that. Because if we add a squared on both sides, take note that a squared minus 2a plus 1 is factorable. But Let's factor first the left-hand side. A squared minus AB factor out A, and we have A multiplied by A minus B. And A squared minus 2A plus 1 can be factored as A minus 1 quantity squared. Now, what can we say about A minus 1 quantity squared? We know already that A and B are greater than 1. Therefore, this A is greater than 1. It follows that A minus 1 quantity squared will always greater than 0. Therefore, we can say that the product of A multiplied by A minus B must be greater than 0. And as we said earlier, A is greater than 1. Therefore, to make the product of A and A minus 1 greater than 0, A minus B must be greater than 0. It directly follows that A must be greater than B. Now, what is A and what is B? We said earlier that A is equal to logarithm of 12 to the base 11 and B must be logarithm of 13 to the base of 12. It directly follows that logarithm of 12 to the base of 11 must be greater than logarithm of 13 to the base of 12. Therefore, which one is greater, logarithm of 12 to the base 11 or logarithm of 13 to the base of 12? And our answer must be logarithm of 12 to the base of 11. And as always, we're done.